Good morning, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the Marketing Director here at the Academy. Here with us today, we have a few folks from the Los Angeles County Sanitation District to discuss their San Gabriel River Watershed Project, which won the grand prize in our planning category of the 2021 AAEES Excellence in Environmental Engineering and Science Awards. We'll have three speakers today. We have Jamie Saar, a civil engineer, Jody Lanza, the supervising engineer, Stephanie, I can't say her name, but it's Olajay Garcia. She's an engineering associate. Before we get started, I just want to mention that you'll be able to message your questions at the end of the presentation. Once the presentation's over, you'll be able to type your question into the attendee chat panel on the left-hand side of your screen. Okay, let's get started. Welcome, ladies. Thank you for joining us today, and we're ready when you are. Jody's up first.
All right, thank you for that introduction. If we can go to the first slide, please. Thank you. Today, as she said, I'm Jody Lanza. With me is Jamie Sayer and Stephanie Olage, and we are happy to present to you our San Gabriel River watershed project to reduce river discharge in support of increased recycled water reuse. And this project in particular, the key part of it was to balance societal needs as well as environmental water needs. Next slide, please. So in today's presentation, I'll start off by giving a brief overview of the Los Angeles County Sanitation Districts, our facilities, and our recycled water program. I'll then hand it over to Stephanie, who will present the recycled water policy and water code section 1211, including all the nitty-gritty details of how to file the petition with the State Water Resources Control Board. And last but not least, she'll then turn over the presentation to Jamie, who will discuss the district's case study, which is the San Gabriel River watershed project. So once again, we're the sanitation district, so I'm going to kind of explain a little bit about our agency. So we are a public agency focused on converting waste into resources like recycled water, energy, and recycled materials. We consist of 24 independent special districts and serve about 5.6 million people within Los Angeles County. The service areas in this map cover approximately 850 square miles and encompasses 78 cities as well as unincorporated areas within the county. And to maximize efficiency and to reduce costs for our ratepayers, the 24 sanitation districts work cooperatively with one administrative staff when we're headquartered near the city of Whittier. However, each sanitation district does have a board of directors, which consists of the mayor of each city and the chair of the county of the board of supervisors for the unincorporated territories. In addition, each sanitation district pays its proportionate share of various administrative costs. Next slide, please. Thank you. The sanitation districts were created in 1923, so we're coming up soon on our 100-year anniversary. But we were created to construct, maintain, and operate facilities that collect and treat domestic and industrial wastewater. We do operate and maintain regional wastewater collection system, and that includes approximately 1,400 miles of sewers, 48 pumping plants, 11 wastewater treatment plants, and we transport and treat about half of the wastewater within Los Angeles County. The wastewater treatment capacities at our facilities range from about 0.2 MGD at our La Cañada WRP, which is the smallest, all the way up to 400 MGD at our Joint Water Pollution Control Plant. And the San Jose Creek WRP is our largest WRP and has a treatment capacity of about 100 MGD. Collectively, currently, we treat about 400 million gallons of water per day, which for those of you that are familiar with the Rose Bowl, it's enough to fill it nearly 5 times a day. And over the last 50 years, we've been the nation's largest producer of recycled water. Now, as you can see here on this figure that's up on your screen, the focus of today's presentation is going to be on our Joint Outfall System Service Area, or JOS. And it's a regional interconnected system of wastewater facilities in the metropolitan LA area. And this serves approximately 5 million people within 73 cities and unincorporated territories. It also serves small areas of the city of Los Angeles, areas within Orange County, and small areas of San Bernardino County. The JOS includes our, like I mentioned before, San Jose Creek WRP, Pomona, Los Coyotes, Long Beach, Whittier Narrows, and then our biggest plant, the Joint Water Pollution Control Plant, and then our smallest plant, La Cañada. However, the joint plant and La Cañada will be excluded from today's discussion. That's because the La Cañada WRP currently provides extended secondary aeration for just about 200,000 gallons of wastewater per day, and it serves the La Cañada Flint Ridge Country Club as well as 425 surrounding homes. So it just has a very narrow use. And the joint plant, which is our facility down in Carson, is a secondary effluent plant, and that's the subject of ongoing analysis for a joint reuse project with the Metropolitan Water District of Southern California. And Whittier Narrows today, that WRP will be included in our discussions because it does discharge flow to the San Gabriel River system. However, we did not ask for a decrease in discharge as part of this project. Next slide, please. So as you can see here on this graph, for over half a century, the sanitation districts have diverted high quality wastewater flows away from being directly discharged into the ocean, and we treated at our upstream WRPs to provide recycled water for eventual reuse. Now, discharge to the ocean has steadily decreased since our WRPs were built in the early 1970s. There were significant drops in effluent production, which you can kind of see here on this map, that occurred in 1977 and 1991. That was in response to there's some very serious drought conditions. And also kind of depicted here, there has been a more gradual but longer term drop in effluent production that's been ongoing since about 2006. This is also due to another water crisis, as we're all aware, that's been going on in the state, and there have been measures implemented, such as emergency declaration and mandatory water reductions by the state. But we're proud to say that starting in 2012, we at the sanitation districts were beneficially reusing more recycled water than that's being discharged and lost. And as of fiscal year 2019-2020, we've been able to reuse approximately 64% of the recycled water that was produced. Next slide, please. So just to kind of give you an idea of some of the current recycled water uses, at our San Jose Creek WRP, water is reused for groundwater recharge at a local forebay, as well as for irrigation, industrial, and municipal purposes. At the Pomona, water from our Pomona WRP is reused for irrigation, industrial, municipal purposes. Those same three uses, irrigation, industrial, municipal, are how the water is reused from our Los Coyotes WRP. And same thing with Long Beach. And then last but not least is Whittier Narrows, and water from there is reused for irrigation and municipal reuse applications. So as you can see in this figure here, the purple bars show the volume of discharge used for recharge of our groundwater basins. And that really varies greatly from year to year, depends on things that are totally out of our control, such as rainfall, runoff, maintenance activities that are going on in the spreading grounds. And so it's kind of inconsistent from year to year. However, the blue bars, which show direct use, show an increase in the long-term trend of recycled water for direct non-potable reuse. Next slide, please. Thank you. So this kind of gives you a brief history of our reuse sites. So in 1970, before the 76-77 drought, we had a total of 6 reuse customers using 21 million gallons per day. As you can see, it's kind of grown exponentially, and by the end of fiscal year 1920, we had a total of 953 reuse sites spread out through 32 cities and within the unincorporated county areas. And to date, we have supplied over 1 trillion gallons of recycled water over the last 50 years. However, while this is an amazing accomplishment consistent with the sanitation district's mission to convert waste into resources, we're still looking for ways how we can provide more water from our WRPs to be reused. But in order to do so, we need approval from the State Water Resources Control Board to reduce our discharge into the San Gabriel River and San Jose Creek so that water can be beneficially reused. So that approval process falls under what's called Water Code Section 1211. So I'm going to now pass it on to Stephanie so she can talk more about that effort.
Thank you, Jody. As Jody mentioned, now we'll get into the California Water Code Section 1211. However, before we get into the Water Code Section 1211, I just wanted to take a brief moment to discuss the state's recycled water goals and its recycled water policy. The executive order issued by the governor in 2014 promotes the development of recycled water to serve areas in need and encourages the State Water Resources Control Board to expedite requests to change water permits to enable those deliveries. In its recycled water policy, the State Water Board set a goal of increasing the use of recycled water over 2002 levels by at least 2 million acre feet per year by the year 2030. An acre foot is equal to about 0.3 million gallons. It covers 1 acre of land, 1 foot deep, and supplies about 2 average Southern California families for 1 year. Also included in its conservation goals is to substitute as much recycled water for potable water as possible by the year 2030. However, before recycled water can be beneficially reused, California Water Code Section 1211 requires that the State Water Board approves it. It is similar to water rights process. More specifically, Section 1211 states that prior to making any change in the point of discharge, the place of use, or the purpose of use of treated wastewater, the owner of any wastewater treatment plant shall obtain approval of the board for that change. Unfortunately, the 1211 process can be long and arduous and often conflicts with recycled water policy's goal of expediting approval for recycled water reuse. There are some instances, however, when a 1211 is not required. Those include when the discharge or use of treated wastewater does not result in decreasing the flow in any portion of a watercourse, or when the wastewater is discharged directly to an ocean or bay. So for example, if we wanted to reduce our joint water pollution control plant's discharge, it wouldn't require 1211 since it directly discharges to the Pacific Ocean. And lastly, if the water being recycled has never been discharged to a water body. For example, if there is new construction and treated wastewater from those homes is beneficially reused before it is ever discharged to a water body. And then the last one is when there is no existing discharge. If you do not meet one of those criteria previously discussed and wish to change the point of discharge, the place of use, or the purpose of use of treated wastewater, then a 1211 petition must be filed. The 1211 has 2 main components. The petitioner needs to address water rights and potential habitat impacts. By decreasing discharges to the water body, will a person or entity downstream no longer have access to the water that they have rights to use? If so, then the water cannot be diverted, even if it is going to another beneficial use. For the San Gabriel River watershed project, the stream is fully appropriated, meaning all water rights are already assigned. The water rights holders downstream of our proposed project are the same agencies requesting the water be diverted upstream instead of beneficial reuse. Therefore, this component has not been an issue on our project. However, impacts have been a major focus of the San Gabriel River watershed project. In particular, the leaf spouts vireo and its habitat have been discussed. In our case, it is not directly the volume of flow like the delta smelt that you may have heard about in the Bay Area. It is the little bird shown on the screen. The Sanitation Districts spent more than 5 years consulting with both the California Department of Fish and Wildlife and the U.S. Fish and Wildlife Service. The Fish and Wildlife agencies are concerned that reduced recycled water discharges to Southern California streams and rivers may adversely affect the aquatic and riparian ecosystems that have grown to rely on recycled water discharges. This is because these stream corridors provide valuable wildlife habitat in our urbanized region. So now that I have covered the broader context of what is required to be addressed during the 1211 process, I will discuss the process steps. First and foremost, an application needs to be submitted to the State Water Resources Control Board by the agency wishing to decrease discharge to a water body. The application must include a complete CEQA analysis. After the petition application is submitted, the State Water Board then evaluates the petition, including a public trust considerations, injuries to other legal users of the water, and other applicable policies, and of course CEQA. If the State Board is satisfied with the petition, Then they post the petition on their website for a 30-day public review period. It is during this time that the public or other agencies are able to review the petition and can file a protest if they disagree with some part of the petition. In the case of the districts for the San Gabriel River watershed project, we filed 4 1211 applications. One for each WRP we were asking to reduce discharges from. So this includes San Jose Creek, Long Beach, Los Coyotes, and Pomona WRPs. The petitions were protested by California Department of Fish and Wildlife, Heal the Bay, and LA Waterkeeper. As will be discussed later in this presentation, the sanitation districts worked closely with both California Department of Fish and Wildlife, Heal the Bay, and LA Waterkeeper to resolve the protests to be able to move forward with our proposed reduction in discharge to support recycled water use while still being protective of the riparian habitat. Once protests were resolved, the state board then issues a draft order followed by a final order. If protests are not able to be resolved, then an additional step of a board hearing may be required. As I stated previously, the first step is to complete a CEQA analysis. CEQA will be needed to support the 1211 permit application, and the main objectives include to disclose to decision makers and the public that the significant environmental effects of proposed activities, and to require agencies to avoid or reduce the environmental effects by implementing feasible alternatives or mitigation measures. Also, to disclose to the public the reasons for agency approval of projects with significant environmental effects, which we were able to avoid having to do that in this case by inclusion of an adaptive management plan, which I will discuss a little bit further in this presentation. And also to provide interagency coordination in the review of projects. We were able to get early feedback and comments from the State Water Resources Control Board, resource agencies, and we also got support of the water community through the CEQA process. And lastly, the CEQA analysis is to enhance and promote public participation in the planning process. This is where we were able to really engage stakeholders for our projects, such as California Department of Fish and Wildlife, the U.S. Fish and Wildlife Service, and other non-governmental organizations. As a result of those studies, no further analysis was needed for other resource areas, with the exception of biological resources, hydrology and water quality, and recreation. After analysis, it was determined that these resources areas would have no impact or less than significant impact. However, for biological resources, implementation of mitigation measures was required, which consisted of an adaptive management plan for the habitat and the establishment of a habitat management committee. Both of those were key project elements and will be further discussed. To analyze the potential impacts that were previously stated and to address concerns raised by the resource agencies and non-governmental organizations, the sanitation districts undertook 3 main efforts. Field studies were conducted, groundwater levels were analyzed, and hydrology analysis was done. At the recommendation of the California Department of Fish and Wildlife, 4 focused special status species surveys were conducted within the San Gabriel River channel below the San Jose Creek WRP point of discharge. The result of the fish survey was that 30 non-native species were observed, but no native species were observed. Additionally, no western pond turtles or tricolored blackbirds were observed. Surveys were also conducted for bats. Although 5 different species of bats were found, the proposed project is not expected to have a negative impact on roosting or foraging habitat, and no direct impacts to wintering or maternal roosting sites would occur. Therefore, impacts to special status bats would be less than significant. Additionally, a general habitat assessment and additional vegetation mapping was conducted to assess the conditions of the project area that are capable of supporting special status species and to confirm the vegetation types and habitat quality within the soft bottom segments of the San Gabriel River and the San Jose Creek that are upstream and downstream of the Whittier Narrows Dam, primarily where riparian vegetation is present. The project area consists of 2 groundwater basins. So there's the main San Gabriel Basin and the Central Basin shown on the screen. as part of the environmental impact report process, questions were raised about the connectivity between the water reclamation plant discharge and groundwater basin levels, since groundwater basins are an important source of water for the area. The annual water demand for the entire vegetated area is 1,945 acre feet, or also it equates to 64 million gallons per year. So based on this analysis, the sanitation districts would need to supply a sufficient amount of water that could be either 1, consumed by vegetation directly from surface flow, or 2, stored in the soil to provide for future needs of the vegetation. Groundwater and hydrology modeling were conducted to verify future needs were met. The groundwater study determined that the strategic recycled water diversions would not reduce groundwater storage at all. The sanitation districts further addresses this by including groundwater levels from surrounding monitoring wells as part of the supplemental data in the spring and fall monitoring reports, which Jamie will discuss later, and discusses with the committee each spring and fall as to how the discharge schemes may impact the groundwater levels. We also did hydrology studies. So these were focused on identifying how existing riparian vegetation is influenced by hydrology along the San Gabriel River and the role of the water reclamation plant discharge in that mixture of sources. It also was tasked to identify whether the project reduction in the volume of water reclamation plant discharge would impact riparian habitat, and whether the project can optimize the location and the frequency of water reclamation plant releases in a way that minimizes habitat impact or even provides a net improvement over the existing hydrologic regime. In other words, we're trying to find a balance between delivering less volume of water, but delivering it with the frequency that is better suited to riparian plant uptake. Although the project includes flow reductions from 5 water reclamation plants in total, this report only considered 3 that sent flows to the earth bottom sections of the San Gabriel River, and that included Pomona, San Jose Creek, and the Whittier Narrows water reclamation plants. For the hydrology studies, a 5-year period was used to establish a baseline against which to evaluate project conditions. The period was water year 2014 to 2018. These water years were selected because they represent a range of conditions, including a mix of wet and dry years. Under existing conditions, the project area receives very variable flows. As shown here, the study area was divided into 11 zones. Now, to determine whether flows could be released in a way that benefits habitat, 6 operational scenarios were assessed that involve varying flow from San Jose Creek Water Reclamation Plant. This involved various scenarios with uniform flow and also with shorter duration, higher rate releases from various discharge points. We looked at the number of dry days under existing and also under project conditions. So this table shows the increasingly dry conditions downstream from San Jose Creek until the Whittier Narrows water reclamation plant under existing conditions. All the operational scenarios show a reduction in the duration of dry periods in the upstream part of the study reach, with some increase in dry periods downstream. In some operational scenarios, there is a net increase in dry periods. For example, operational scenarios 1A, 1B, 2A, and 2B all cause a net increase in the number of dry days. However, operational scenarios 1C and 2C show a net reduction in dry days, and thus potentially offer a benefit over existing conditions. The potential benefit occurs because water is released in a more regular pattern, as well as being concentrated to overcome the percolation areas upstream and deliver water downstream. So, operational scenario 1C resulted to be the best scenario. The dry period analysis shows this scenario performing slightly better than existing conditions, with fewer days of no flow in the channel because of the combination of regularity and concentrated flow. This scenario was a good starting point for the adaptive management plan, in which flows are controlled and vegetation response monitored. So now the next step of the process was to develop an adaptive management plan, and you heard me explain a little while ago. This was developed as a mitigation measure in the environmental impact report to ensure the impact to biological resources would be less than significant. So the Adaptive Management Plan was developed in coordination with the California Department of Fish and Wildlife and also with the United States Fish and Wildlife Service to protect the habitat along the river while seeking to provide more recycled water for the region. It includes annual mapping of vegetation that will assess quality as well as quantity of habitat. It also identifies parameters that would provide early detection and trigger actions to remediate any potential effects that are attributable to the proposed reduced discharges. And lastly, the Adaptive Management Plan established the Habitat Management Committee, which reviews the habitat conditions and identifies when and if adaptive management actions are needed. The committee reviews collected data annually to verify protective responses. The overall goal of the plan is to maintain habitat at its existing level or better while making more recycled water available to the community. So the Habitat Management Committee is a key component and something that sets this project apart from many others and goes to the theme of balancing water needs for the habitat and for human use. The committee includes staff from the sanitation districts, representatives from U.S. Fish and Wildlife Service and California Department of Fish and Wildlife, the Los Angeles County Department of Public Works, Southern California Coastal Water Research Project, the United States Army Corps of Engineers, water management and supply agencies, and environmental and other non-governmental organizations such as LA Waterkeeper and Heal the Bay. The committee meets twice a year and provides direction, if needed, for the project. So now the next step is to submit the 1211 petitions. In the case of the districts for this San Gabriel River watershed project, we filed 4 1211 applications, one for each water reclamation plant we were asking to reduce discharges from. That includes San Jose Creek, Long Beach, Los Coyotes, and Pomona water reclamation plants. Once CEQA was complete, we completed the 1211 applications that are shown right here on the screen. Although the form looks relatively short, there is a lot of information that goes into this petition. Items necessary include a description of existing conditions and changes to the point of discharge, the place of use, or the purpose of use, what the reduction in discharge to a watercourse will be, answering questions on contracted water, addition of environmental information, including the project description, photographs, maps, how we will comply with CEQA, and many other things. In cases like the San Jose Creek water reclamation plant, we have 5 discharge locations. We have numerous recycled water contracts, and we have a long history of alternating discharge locations and volumes. So you can imagine this gets very complicated to explain. In addition to all that, then there are suggested attachments that include providing rationale to support findings regarding impacts to fish and wildlife or legal users of water. So this simple looking form can turn into a several hundred-page application by the time it is submitted. Then, in addition to all these, there are fees associated with submitting the application, which are intended to cover the time for State Water Board staff to review the petition. As mentioned previously, this process, intended to be expedient to follow the recycled water policy, can be very time-consuming. After the petition application is submitted, the State Water Board then evaluates the petition. If the State Board is satisfied with the petition, then they then post the petition on their website for a 30-day public comment period. It is during this time that the public or other agencies are able to review the petition and can file a protest if they disagree with some part of the petition. For our particular project, the petitions were protested by the California Department of Fish and Wildlife, Heal the Bay, and LA Waterkeeper. The sanitation districts worked closely with the California Department of Fish and Wildlife, Heal the Bay, and LA Waterkeeper to resolve the protest to be able to move forward with our proposed reduction in discharge to support recycled water use while still being protective of the riparian habitat. The fish and wildlife protests were resolved once the final environmental impact report was approved. The sanitation districts committed to fulfilling the adaptive management plan and committed to complying with all mitigation measures specified in the final EIR. Now, to resolve the protest from LA Waterkeeper and Heal the Bay regarding Calvert trapping and recreational usage, the sanitation districts committed to expanding the monitoring and control of cowbird nests on its properties for 10 years as part of efforts to avoid adverse impacts to the endangered leaf-spouts vireo. This commitment greatly expands the time commitment for this aspect of leaf-spouts vireo mitigation, well beyond the commitments made in the environmental impact report, which was 3 years. LA Waterkeeper and Heal the Bay were also concerned with the dearth of supporting information, particularly with respect to baseline information on recreational uses. The Sanitation District addressed this concern by designing a recreational usage study that will provide non-anecdotal data for the first time regarding existing recreational uses of the channel and levees. The results of this survey will provide a valuable contribution to the understanding of the extent of existing recreational beneficial uses and will help inform management decisions by the sanitation districts and the recommendations of the Habitat Management Committee going forward. So what is cowbird trapping? First, I want to describe what brown-headed cowbirds are. So they're obligate brood parasites that lay their eggs in the nests of other bird species, and they rely on the host to incubate the eggs and raise the young. The leaf-spouts vireo is a federally listed species that have suffered population declines, primarily because of extensive habitat loss and degradation. Declining populations and their dependence on increasingly reduced, fragmented, and degraded habitat lead to a heightened threat from cowbird parasitism. Implementation of cowbird trapping during the nesting season has proven to be a successful management strategy. Cowbird trapping typically involves traps that are about 6 feet tall, 6 feet wide, and 8 feet long to capture cowbirds. The sanitation districts had a very successful year of cowbird trapping, during which 91 total cowbirds were captured, and of those, 24 were female. And this is important because the capture of those 24 females removed the threat of parasitism to as many as 960 native bird nests, since they can lay as many as 40 eggs in the nests of other birds in a single season. So now we go on to the recreational usage study. We're currently in the process of conducting the recreational usage study, and within this study, we monitor 3 sites, as shown on the figure, dotted in green. And we go out here about 6 times per month for 12 months, which started middle of last year, so we'll be ending the middle of this year. And it takes about 50 minutes at each site. So the purpose is to look for recreational uses such as walking, jogging, biking, photography, fishing, swimming, equestrian activities, things like that. And overall results indicate that the project is not impacting typical recreational uses of the area, since most uses include biking, walking, horseback riding, etc., that are not impacted by the amount of water in the river. Okay, so now we move on to the next step. So once the protests were resolved, the state board issued a draft order. It was followed by a final order. So finally, the State Water Board approved the project petitions. They were, for San Jose Creek and Pomona, they were approved in October of 2020. For Long Beach and Los Coyotes water reclamation plans, they were approved in May of 2020. So now this means that we can proceed. And now I'll turn it over to Jamie to discuss the San Gabriel River watershed project.
Thank you, Stephanie. As she mentioned, I will be presenting the project and some of the preliminary results of the San Gabriel River watershed. So our project has 2 main objectives. The first objective is to be consistent with state law and policy, support increased recycled water use through maximizing the availability of treated effluent that would otherwise be discharged to flood control channels within the San Gabriel River watershed. The second project objective is to sustain or, if feasible, enhance sensitive habitats that have benefited from historical treated effluent discharges to the San Gabriel River watershed through more efficient discharges from the sanitation district's water reclamation plants. Ultimately, our project will help identify the balance between habitat management and water sustainability for the San Gabriel River watershed. The locations of the 5 water reclamation plants are shown on this figure. Pink represents the concrete-lined portions of the San Gabriel River and some of its tributaries, while the green portions represent the natural bottom channel areas. The project study area includes the San Gabriel River, San Jose Creek, and Coyote Creek. So why does this project have to go through a 1211 process? It's because the proposed project is to incrementally reduce discharge from our water reclamation plants, Pomona, San Jose Creek, Los Coyotes, and Long Beach, and to support the local efforts towards water sustainability. In order to change the place or purpose of the use of treated wastewater, as Stephanie previously presented, we must obtain approval from the board for that change, even though this reduction from all plants is not going to happen all at once. They are being considered as a whole in this project because the resource agencies had requested the districts to evaluate cumulative impacts for all discharge reductions in the same river and watershed. As you can see here, the Pomona Water Reclamation Plant currently discharges to the lined portion of San Jose Creek. Whittier Narrows, which isn't going to impact this project but is part of the watershed, so included for discussion, can discharge to both the San Gabriel River and the Rio Hondo River. Rio Hondo is also part of the LA River watershed. Although we are not reducing the discharges from Whittier Narrows as part of this project, it contributes to the watershed and is included for discussion. San Jose Creek has 5 discharge locations, 2 at the confluence of San Jose Creek and at the confluence of San Jose Creek and San Gabriel River, 2 in the natural bottom, and 1 in the concrete-lined portion of the river. Los Coyotes also discharges to the lined portion of the river, and lastly, Long Beach discharges to portions of Coyote Creek down here in the southern portion of the watershed. Next slide. This discharge can provide up to 35 million gallons per day of recycled water for human use, which equates to greater than 39,000 acre-feet per year of water being used for reuse projects in place of purchasing imported water in place of being discharged to the San Gabriel River. This water accounts for enough water for 350,000 people, and not importing the 39,000 acre-feet per year saves our region about $40 million per year in energy costs. Given that the projects haven't been implemented yet, the discharge schemes are at or close to the baseline discharges presented here. Once the project is implemented, the discharges will be as follows. San Jose Creek will be reduced to approximately 5 MGD. Pomona will be reduced completely to 0 MGD. Whittier Narrows, again, will not be reduced as part of this project. Los Coyotes will be reduced to 2 MGD, and Long Beach will be completely reduced to 0 MGD. Next slide. Although our project area covers a large portion of the San Gabriel River watershed, the figure on this slide depicts the location of the habitat that is most directly impacted by the project activities. As you can see here, this area covers from the confluence of the San Gabriel River and San Jose Creek down to the Whittier Narrows Dam and a little bit below the dam. As Stephanie previously presented, since the San Jose Creek outfall number 2 is located here at the confluence, and you can kind of see it on the map, it will have the most impact on the habitat. The riparian habitat presented here is potentially impacted by the project, includes portions of the San Gabriel River above and below the confluence with San Jose Creek, a portion of the San Gabriel River just downstream of the dam, and other off-channel areas that receive water from San Gabriel River known as the Zone 1 ditch, the Whittier Narrows Dam cross-channel. The habitat can be defined in groups 1 through 5, depicted in the different colored squares. 1, depicted in blue, is often flooded due to the presence of weirs. Group 2, depicted in green, is occasionally flooded, but ponded water percolates quickly in this area. Group 3, which is in yellow, mostly contains water during winter months. Group 4, which is in orange, is a low point in the dam area, so groundwater is closer to the surface in this group. And lastly, Group 5 may be impacted by our project because water can be diverted across the Zone 1 ditch. And Group 5 is the area in red. The Adaptive Management Plan presented monitoring parameters such as water stress and annual vegetation mapping of existing vegetation to help determine whether the vegetation is substantially stressed from lack of water, such that there is a reduction in habitat function and value. The Adaptive Management Plan's purpose is to sustain riparian and wetland vegetation habitat at pre-project levels. Stem water potential, or SWP, is the pressure tension expressed in atmosphere required to express a droplet of water from the fresh-cut end of a sample leaf. Proxy for plant drought, and if the tension exceeds the ability of the plant to make the diurnal nighttime recovery, the water column in the plant can cavitate, leading to permanent wilt and leaf and stem death. Therefore, the higher the value of stem water potential, the more drought stress is being experienced by the plant. Canopy volume, or CV, is a numerical evaluation of canopy condition interpreted as canopy volume of the tree that was sampled for stem water potential. Position, or PO, is assessed by assigning one of 4 codes to the location of the individual tree in relation to the adjacent drainage feature. Substrate, represented by SU, is used to characterize substrate conditions at each tree or shrub sampling point. Substrate types are classified based on sediment size. Canopy structure, or CS, is a numerical representation of habitat structure, including the understory based on the Coos method, which I'll present a little bit more about in a couple of minutes. Species richness, or SR, is a tally frequently occurring plant species observed that provide vegetative cover over a 2-meter wide survey area along the transects between quadrants. And that's in your sampling areas. Recruitment, or RE, is a numerical summary of recruitment expressed as juvenile trees and shrub or subshrub species. And obviously we want the recruitment to be of native plants versus non-native invasive plants. And vegetation mapping, or VM, is performed with a ground truthing to alliance level with quantitative summaries of each alliance type present in each monitoring group. The mapping is performed on an annual basis with the most recent aerial photographs available. And we are typically flying these, the aerial photographs are collected and flown in April or May of each monitoring year. Next slide. The Adaptive Management Plan established monitoring objectives, and these have been prepared to guide evaluation of the habitat conditions and to suggest triggers for implementing adaptive management. The overall objective is to more efficiently manage effluent to maintain the quantity and quality of the riparian habitat in areas currently influenced by treatment plant discharge. After project implementation, for example, if we're reviewing data for stem water potential or canopy volume, and we see any statistically significant decline for a species or for any species or any group from that baseline data for that group or species, a significant decline will indicate the potential for an adaptive management trigger. And you can see what these some of these baseline uh, conditions are. A trigger for adaptive management would be a decline of 1 standard deviation or more from the baseline mean in canopy volume as measured as a stacked cube, looking at the different increments in each of the cubes. And I'll talk about that a little bit more and what that means in a couple minutes. But basically, that is that all the quadrats sampled in each group, a minimum of 20 quadrats per group, would be combined to attain a single canopy volume mean and associated standard deviation within each sampled stratum for that adaptive management group. And then looking at recruitment, for example, it is an episodic event in riparian systems, and therefore recruitment and also species richness will be evaluated against this monitoring objective matrix every 2 years rather than annually. Data and monitoring data for recruitment and species richness are collected annually, but again, we review those results against this on a every other year. The goal for the habitat is that the area will remain generally undiminished. A detectable change of habitat percentages, as shown in this table, will trigger an appropriate response. If it is agreed upon that the habitat changes are not detectable on an annual basis, or if suitable aerial photographs are not available, the frequency of mapping may be modified. Since the data from both the 2019 and the 2020 monitoring years were used to establish the baseline conditions, any statistically significant differences identified between these 2 years are due to natural variation. Additionally, the 2019 year represents a slightly wetter than average water year, while the 2020 year represents a slightly drier than average water year. And as you can see, stem water potential is included as a data category during surveys as an early indicator of stress of the trees along the project area. And we noted that it did turn out to be slightly higher in 2020 versus compared to 2019, which was expected, given that it was a slightly drier year than average. Canopy volume, however, was slightly higher in 2020 versus 2019, which suggests that there might have been some water availability in the watershed that was sustaining the canopy. We didn't note any significant difference with any change in the baseline conditions between 2019 and 2020 for position or canopy structure or even species richness. Recruitment was slightly lower in comparison versus, again, we did not collect substrate values in 2019. It was a new classification parameter that we collected in 2020. And then regarding vegetation mapping, we collected aerial photographs in the spring of 2020, but we did not collect those in 2019. And so the 2020 photographs are acting as our baseline for the vegetation mapping conditions. Okay, so this is the same figure as I previously presented, but I wanted to kind of remind everyone where we were in the watershed and where our little habitat area is and how the groups are situated within the watershed before I moved on to the next discussion about some of our additional baseline results. So canopy structure is kind of one of our more, it's an interesting parameter that we measure. And it's also known as the Coos stacked cube method. And it records plant cover by species in a stacked meter cubes by classes. Each cube is 2 meters wide by 2 meters long by 1 meter high. Each cube represents an area of 4 cubic meters. Canopy structure data were collected for each cube stacked to 6 meters. Now, this is because least Belvero nesting habitat is typically within 6 meters of the ground, and therefore additional data were not collected above that 6 meter height. Canopy structure is an important characteristic of vegetation that determines its suitability for least Belvero habitat. And the Coos method was specifically developed to determine the optimal habitat for nesting least Belvero, with data having been collected in the immediate vicinity of known least Belvero nests. Data collected from other riparian vegetation can be compared to the optimal condition data to determine how suitable the riparian vegetation may be for least Belvero occupation. In this case, data were collected to characterize the existing vegetation before the onset of the project. In subsequent years, changes from these baseline conditions can be evaluated by resampling the same quadrats and transects and comparing the data. It is acknowledged that current conditions may be poorly suited, or current conditions based on the baseline conditions, that is, may be poorly suited as least Belvero nesting habitat. It is one of the goals of the projects to release water on a schedule, as Stephanie mentioned, that will sustain or may possibly improve these habitat conditions. Each species was evaluated as a percentage of the overall canopy structure. These figures, and this is that are presented, this is group 1 and group 2, show the total cover percentage for the stacked cube assessment for data collected during the 2019 and 2020 surveys for these groups. These include a median line, the 25th and to 75th percentile range, which are represented by the boxes, the 10th and the 90th percentile range, which are represented by the whiskers, and the values beyond those limits, which are known as the outliers. So those are just the little dots. The height of each cube is represented as B0 to 1, which is ground to 1 meter, B1 to 2, which is 1 meter to 2 meters, and so on up to B4 to 5, which is 4 meters to 5 meters, and then greater than 5 meters, as you can see out here. Additionally, the published habitat suitability limit for least Belvero, which is represents a mean canopy structure plus or minus 2 standard deviations, is presented in red. And as you can see, those are the same values in all in both groups, and they're represented in again and compared against all the groups. Next slide. Preliminary monitoring results from the fall 2021 effort indicated that 3 adaptive management plan triggers were met. However, these were identified: canopy structure, recruitment, and vegetation mapping. However, there were several potential causes for these fluctuations in measured values for these parameters, such as the record low rainfall. We had less than 6 inches of rain during water year 2021. There were human disturbances and at least one fire caused by homeless encampments, and there were regularly scheduled flood control maintenance activities performed by Army Corps of Engineers, and flood control districts. Therefore, we feel it's important to consider these factors when assessing the need for any mitigative action. Additionally, we found that Group 1's mean canopy volume fell below the lower limit of the 95th percentile confidence interval, which indicated a statistically significant change took place and that mitigative action might be considered. However, the main reason for this drop in canopy volume value was directly related to the impacts associated with the homeless encampments, which was evident during sampling activities. And our sampling and survey crew noted a lot of those activities and noted the locations of those activities in their field records. Also noted during the fall 2021 monitoring survey was that the LA County Sheriff's deputies were in the process of removing the homeless encampments. And therefore, our understanding is that, or hope is that future canopy volume impacts associated with the homeless population should be reduced or eliminated. Although the data indicate that there might be a need for discussion of mitigative action, the cause for the Group 1 mean canopy volume value to drop below the lower limit of the confidence interval is a direct result of impacts associated with homeless encampments and should not require additional action at this time. Should the canopy cover continue to diminish following the 2022 sampling, then action may be required and would be discussed. Next slide. Again, just a reminder that the project was implemented in December of 2020. However, as one can see in this figure, although the project has been implemented, we're still experiencing combined discharges that have not been reduced below the baseline discharge that was presented in the 1211 change petitions. As you might imagine, our project has a lot of ongoing efforts. We are continuing to refine the statistical analysis process through which we will use the baseline conditions to determine if an adaptive management trigger has been met. The baseline conditions, as established through the 2019 and 2020 monitoring efforts, will be used to benchmark the changes in the habitat. Each spring and fall, we will perform monitoring of the habitat area using the parameters that we presented today. Cowbird trapping will continue each spring through early summer, the least Belviro nesting season, and will begin again later this month. As Stephanie mentioned, that is a 10-year process that will continue annually. The recreational usage study will wrap up this July, as that was only a year-long study. Throughout the length of the project, we will continue our ongoing coordination with the Habitat Management Committee, meeting in the late spring and late fall to discuss the results of the habitat monitoring and share results, findings, and field observations that we've collected throughout the year. So, how much does all of this monitoring and data collecting cost? Well, it's an estimated $160,000 per year, and that's just for the monitoring base, essentially. So as you can see, the recreational usage study is approximately $60,000 per year. And again, it's important to note that that's just for 1 year. The habitat monitoring, for the monitoring itself, in the spring, it's around $25,000, and in the fall, it's around $50,000. And the cowbird trapping is annually around $20,000. Now, that again is just for monitoring associated costs. It doesn't include writing other reports like the statistical analysis or the field and monitoring protocols that we've put together for the HMC. It doesn't include costs of meetings, and it also doesn't include the district staff time for review, coordination, and overall project management. As with any project that's gone on for this long and has all these moving pieces, our team has learned a number of lessons moving through the process. So we recommend involving the resource agencies early on in the process, which gives them time to communicate and coordinate with us and helps to improve project implementation. We recommend continuing this coordination with the agencies, making it often, and while you're doing that, be very transparent, keeping the channels of communication open through throughout all project activities. Findings such as the homeless activities and other potential non-project related impacts. And these are also important things just for our partnerships with other agencies as well, and their activities, such as like Flood Control District and U.S. Army Corps channel maintenance and cleanup. It's important to kind of let them know what we're seeing out there and what they're seeing out there, and keeping that communication open. It's also very important to maintain a detailed schedule with this project. As I mentioned in the previous slide with our project cost, district staff perform a lot of coordination and project management for this project, and that includes the maintaining a project schedule, and that's with the consulting teams, the other agencies, the Habitat Management Committee, and internally. We're still fine-tuning the optimal times to reduce flow for stem water potential measurements to be collected. As we've mentioned a number of times, we're trying to refine and better make our discharges more efficient and effective for maintaining the habitat in that area as well. So that's all part of maintaining a broad project schedule. And then again, ultimately, just going back to our main project objective, and that's, striking that critical balance between supporting the East Belviro habitat and also supporting our local water demand needs. And so now we invite your questions.
Excellent. Thank you so much. Now I'll take a few minutes to answer some questions. If you do have a question, just type it in on the left-hand side of your screen where it says attendee chat. Our speakers will just go ahead and answer those questions as we see them come in. Okay, so do you see the first question from Wendy?
I am looking. So I see one question that mentions they believe recycled water discharges to water bodies while reused waters, the effluents are used for irrigation. It looks like they're talking about maybe terminology being used. Is that the first question you're seeing on your end as well, Marissa?
No, that's okay though. There's 2 spots for questions. You can go ahead and answer those.
All right. So this comes from Nadir, and his question relates to, like I said, terminology, and he believes that recycled water is discharges of wastewater treatment plants to water bodies, while reused waters are the wastewater treatment plant effluent used for irrigation, industrial, and reuses. And I believe that is correct. Sorry if we misuse some of those throughout the presentation. I guess that was our mistake, but that is correct. That recycled water is basically stuff that comes out of the discharge to water bodies, and reused water is stuff that's actually reused for beneficial uses. And there was also a follow-on question that I can see is, based on what I understand from this presentation, complete reuse of wastewater discharges is not allowed by regulatory agencies. I guess it depends on the situation, right? So if you do want to completely use all of your discharge and you are currently discharging to a water body, you would have to go through that whole 1211 process that Stephanie talked about. So it really kind of depends on your situation. For example, at our Pomona WRP, we are permitted now to go down to zero discharge, but we did have to prove we would have no impact to downstream water rights uses or to the downstream habitat. So it's really dependent upon your individual situation and as well as permitting that you are able to receive from the water board.
Okay, now on the left-hand side of the screen in attendee chat, do you guys see those questions yet? You have to click on attendee chat. I can just read. Wendy Wirt has a question. She said, thank you for the excellent presentation, Jody, Stephanie, and Jamie. Stephanie, you mentioned that the 1211 petition for change process can be lengthy, and even after your several hundred-page submittal received protests related to lease, bells, vireo, recreational usage, and cowbird trapping. How long did it take you to address all of the protests?
Thank you, Wendy, for your question. So we received the protests, I think, early last year, or sorry, 2020, and we had resolved it within, I want to say, within the year, Jody, if I'm not mistaken. We were able to resolve the protests with LA Waterkeeper and Hilda Bay for those two different protests that they had for recreational use study and for the cowbird trapping.
So yeah, and just I guess to add a little bit to that, it is true that we were able to resolve them relatively quickly, but I think the reason that we were able to do that, a big part of that was because we did have all these communications up front with the various folks. And so we somewhat knew that they were going to be protesting what we submitted and we knew what their issues would be and kind of, so we were able to sort of have somewhat of a rebuttal and kind of thoughts and actions of how we would address the protests. And so kind of that upfront communication and working together helped resolve the protest in a quicker manner.
Great. And then the next question, just from Emily Arena. Just to clarify, the AMP was developed as a mitigation effort for impacts of the project, correct?
Correct.
Okay.
Well, yes, sort of, but I mean, yes, it was part of our mitigation measures, right? But the whole goal of the project is actually not to impact the riparian vegetation, right? So that's the sanitation districts point of view, right? That our project, we can go down to our discharges that we applied for without impacting the habitat. And so we did have a mitigation measure, right, to develop this AMP. But I mean, it's not necessarily to mitigate for impacts because we're saying we're not going to have an impact, but it's to prevent the impact from happening.
Excellent. Thank you. And a question for Jamie from Wendy again. You mentioned that 5 WRPs are involved in the San Gabriel River watershed project. So you evaluated incremental reductions from all 5 plants as one project. How much water could be available to offset imported water in our region?
I'm sorry. I was trying to find her question and I'm not finding it because I wanted to
That's
read it.
okay. It's up top. There should be a little speech bubble on the icons up top.
Okay.
I can go to that slide, Jamie, if you want to review where all the baseline and discharge.
Right. So, Wendy, we were looking at potentially as much as 35 million gallons per day.
There you go.
Yeah, would be available. So for each one, I mean, are you looking for numbers from each WRP or just a total?
Maybe you could just give a total.
Yeah, so we're like I said, we're going to be able to use up to 35 million gallons per day. that would offset that much imported water. And it looks like, did you add to the question? Okay. Thanks, Wendy. I wanted to make sure I was answering your question fully. I didn't want to I didn't want to miss any of it.
That's perfect. Thank you. There's another question from David Lipsky. What is the source of funding for the research, and what impact will this have on ratepayers?
So to this point, the source of the funding has all been internal, right? The sanitation districts have been covering the cost of all the efforts to implement this project. And in terms of the ratepayer, so to date, it hasn't really had much of an impact. So this is one of those cases where we're fortunate to have a very big system. And as you know, as I mentioned in the beginning, we have the joint outfall system that has about 5 million customers. And so when you spread out that cost over such a large ratepayer base, it doesn't really have so much of an impact on our rates. So at this point, there's really not been an impact to the ratepayers. Their rates have not changed as a result of this project, but we have, at the sanitation districts, have been funding the various studies and research that's gone into implementing the project.
Okay, understood. One more question from Wendy. Let's see here. Oh, no. Yes. You showed how that the sanitation districts have several plants that contribute water to the San Gabriel River watershed. How comprehensive is your plan? Does it just cover WRPs, or are you also monitoring other inputs such as stormwater?
So the 1211 process and our particular reductions are just the WRPs. However, we did look at, when we did our studies, the watershed as a whole, how much water would the riparian habitat see, right? So that does include stormwater, how much groundwater pumping is there, or is there, various things going on within the watershed. So when we did our initial studies to see essentially what water would the vegetation see, we did look at all the inputs, rainwater, and then in our annual reports, we do provide the committee with data, like I said, rainwater data, stormwater data, discharge data. So they get a whole picture of kind of the water that the plants are seeing. But in terms of reductions, that's just from our WRPs.
Okay, great. A question for Stephanie. You talked about a comprehensive water management plan that takes into account frequency of delivery. Do you have a real-time model? How does your plan help streamline committee decisions? And that's in the left-hand panel, the attendee chat panel.
Sure. So we don't have a real-time model. We did the analysis based on the water years 2014 to 2018, and we did the hydrology and groundwater analysis, I believe, in 2018 and 2019. And what was the second part of that question? Sorry.
Do you have a real-time? How does your plan help streamline committee decisions?
Sure. So as Jamie presented in her portion, so we take into account or we monitor those 8 different parameters on a yearly basis, and some on a semi-annual basis. So in the spring we monitor about 4 of those metrics. In the fall we do 8 of the metrics. So we meet with them on 2 times a year, and we give them the results, and they see whether or not, based on that trigger matrix that Jamie presented, and whether or not they fall into that confidence interval or within the standard deviations. Each metric has its own way of calculating the statistics. So we present that information to them, and if they see that we are above or below a certain trigger, they then can make the decision to cease or continue discharge. So we stop our project, and we continue the discharge to the river until we all come to a resolution. So in the case for 2021, as Jamie presented for fall, we did have some metrics that were met, the triggers that were met, but as you can see, there are other potential causes that we also look into. So it's not all just based on our discharge. And as Jody mentioned as well, we look at other things that's going on in the watershed, such as stormwater, rainfall. We look at groundwater monitoring wells, their groundwater levels. So we present all of this to the HMC each time we meet with them so that they can make an informed decision on what to do next.
Excellent. Thank you. That looks like it's it for questions. So thank you, everyone. And thank you, Stephanie, Jody, and Jamie, for sharing your knowledge with us today. If anyone has any additional questions, please feel free to email our speakers directly or email me and I can put you in touch with them. Our next webinar will be on Wednesday, March 23rd, when Dr. Mita Panu, a senior scientist at Orange County Water District, discusses their PFAS treatment study. You can go to aaees.org and go to our events page to register. And just a reminder, if you're not yet an AAEES member and are considering joining the Academy, please email me to discuss our membership options. My email is mwaterman@aaees.org. We will have a recording of this event up on our website by tomorrow. And that's all for today. So thank you so much and have a great day. Bye-bye.